A rectangular sheet of metal has dimensions 15 meters by 20 meters. Square corners are to be cut out of it and it should be folded and welded to make a container. Calculate the dimensions for the container to have maximum volume. Alright, so people, this is an example of a situation where we can use differentiation to find a maximum or a minimum value I should say. In this case, maximum volume. All right. So remember, in some cases, you want maximum volume. In other cases, you might want minimum cost or minimum amount of material or something like that. But in this case, we have a set amount of material and we want to calculate maximum volume. When we can find maximum volume, we can find how much we're going to maximize the amount of whatever is in that container that we can sell and make maximum profit from it. So that's why we want maximum volume. All right. Now, here, 15 by 20 meters. Well, let me see. It would, if I should have this rectangle and I label it, say we have 15 by 20 meters here. Let me put it more like what it should look like. 15, 20, yeah, probably that. So we have 15 meters over here, 20 meters across. All right. Now, we're going to cut square corners. So we're going to cut off here, cut off here, cut off here, and cut off here. I gotta cause that line to lean. Let me see now. All right. So that is what we have. Then after that, what we will have is a situation like this. Let me draw it under here. We're going to have this, 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 this. Tula. Let me see now. I want to line it up with that. All right. This, 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 this. All right. So we have that. And then remember, we're going to fold it along these dotted lines. The dotted line should have been straight. All right. And when we fold it, we're going to form a container. And remember, we're going to weld the sides together. So what will the container look like? Let's try and have some idea what the container would look like. So we fold. Have something like that, all right? Now, the thing is, when you cut alongside here, you can cut off 1 meter from each side. But if you cut off 1 meter from each side, then you're going to have 18 wide by 15 minus 2 is what? You remember, it's 1 meter from each side, you know. So the 15 going to lose 1 meter at the top, 1 meter at the bottom. We're going to go down to 13 by, and the 1 meter that you cut off would be 1 meter high. So if you do this, what you're going to have is a situation. We're just guessing first before we do calculus. 18 by 13 is what? 18 by 13 equal by what? 234? Alright? Equal 234. But suppose you cut off 2 meters from each side. It's going to be 2 from the left, 2 from the right. That's a total of 4. Leaving 16 wide times 2 from the top, 2 from the bottom. That's a total of 4, leaving 11 high or wide. Well, 16 long, 11 wide, and how much high? 2. Because the corner would be 2. And if you do this, then what would happen? Get back our calculator. Where was our original calculator? I don't want this calculator. This is a calculator that I was using. So 16 by 11 by 2 equal 352. But who told you that if you cut off 2.5, you wouldn't get a larger number? Right? Suppose you cut off 3 from each side. 3 to the left, 3 to the right would be 6. So this 20 has gone down to 14 by 3 to the from the top, 3 from the bottom, that would be 6. So this 15 had gone down by 2, 9. 9 and 6, 15 times, and it would be 3 high. So if you do that, you're going to calculate a certain volume. What would that volume be? It would be 14 by 9 by 3 equal, right? And if you cut off 4, 4 2 is 8, the 20 would reduce to 12, it lose 8, times, and the 15, 4 from the top, 4 from the bottom, that's a total of 8, 8, 9, 10, 11, 12, 13, 14, 15, it will be times 7 times, and the 4 high, 336. It's dropping. So it went up and then it dropped. So it's between 2 and 4 that you would have to cut off. You notice when you cut off 1 from each side, it was at 234. You cut 2 from each side, it went up to 352. You cut 3 from each side, it went up further to 378. You cut off 4 from each side, it's dropping back down. There is some maximum there between 3 and 4, but where exactly is it? Well, we can't spend all day trying different numbers, adjusting up and down, right? We have to have some method of directly coming to the value that we want. So let us see how it will go. You don't know how much you need to cut off from each side. So suppose you call it X. You cut X from here and X from here. Remember, you're removing square corners. So, the measurement you would have here, well, you had 20 first. But remember, you cut x from here and x from here as well. So x to the left and x to the right means from here to here. Let me draw the arrow properly. From here to here. What will be 20 minus 2x? Whatever x is, you see that? You have 20 all the way across. And you take off 20x from the left and x from the right. So you take 2x is from the 20. So you have 20 minus 2x, right? And then from here to here would be what? Remember, we're lining up across. See that? X from the top, x from the bottom. So this measurement would no longer be 15 meters. What do you think it would be? It would be 15 minus 2x meters. All right. So when you fold and weld the metal, you would have x high by the length would be 20 minus 2x by the width would be 15 minus 2x. You see that? Make sure you understand it, you know. So, here, the volume of the container would be x times 20 minus 2x times 15 minus 2x. You see that? Now the thing is, you want to multiply out the brackets. So what you have is the volume equal. Let's multiply out the brackets first and then times the x now. X times, all right, 20 by 15 would be 15 to 30, 300, right? Now, let me see something for, yeah, so 20 by 15 is 300 plus 20 by negative 2x, 22 is 40, so it's negative 40x. Then negative 2x by 15 would be negative 15 to 30x. Then negative 2x by negative 2x would be a positive 4x squared, right? And x times all of this. Now what would that, all of that give you? My. Hold on there. Yeah. So, when you multiply the x by the bracket, you have 300x minus 40x squared minus 30x squared plus 4x cubed. You see that? That is what you would have. So, the volume equal, you have, let's put the highest power of x first. You have 4x cubed. Here you have negative 40x squared minus 30x squared. That would be 40, negative 70x squared plus 300x. All right, you see that? After that, now, the thing is, this is a cubic function. All right, so you will have something somewhat like this, but there is a local maximum and a local minimum. How do you find out exactly where the maximum and minimums are? You remember? You differentiate this function. When you differentiate, what you find is the gradient function. And the gradient at the maximum and minimum is 0. So you equate it to 0 and solve. You see that? So, we see what happened here. Let's get rid of this. So, you find the v by the x. That means the rate at which x is changing as v changes. Alright? As the volume change, how is x changing? That is what it is saying. Now, here. This, when you differentiate it, remember, the power rule. The power 3 times 4, which is 12, x to the 3 minus 1. But 3 minus 1 is 2. So let's write the 2 there. Alright? Then the power 2 times negative 70. So it's negative 70 by 2, which is 140 x to the 2 minus 1. I have to remember that. So, but 2 minus 1 is 1. Well, x to the 1, you can leave off the 1 and just write x. Alright? Plus, the power of x here is 1. So you say 1 times 300. So it's 300 x to the 1 minus 1. But 1 minus 1 is 0. But what is x to the 0? X to the 0 is equal to 1. So you don't even have to write it. So here now, this is the gradient function. And it is equal to 0 at the stationary points. Well, 2 stationary points here. So here now, that is what we have. So we must solve this. So we have 12x squared minus 140x plus 30. You can pause the video and solve it and tell me what you get. Alright, let us solve it. We can get smaller numbers, you know. Let me see. Suppose we divide by 2. We have 6x squared minus 70x plus 150. Oh, we could divide again, you know. Or we could have just divided by 4. Right? Alright, so divide by 2 again. We have 3x squared minus 35x plus 75. Alright, we have to just let it stay. We can't divide any further. Now, we can use the quadratic formula to solve this. Alright? So x equal negative b, which is negative 35. It's 35 plus or minus the square root of 35 squared. Well, it's negative 35 squared. Alright. Minus 4 times 3 times 75. All over 2 times 3. Which is 35 plus or minus. We're going to have to figure out what is under the bracket here. So, when you work it out, you have 35 squared. Negative 35 squared give you the same thing. 35 squared is 12,250 minus 4 3s is 4 by 3 by 75 equal 325. And then the square root of 325. Square root of that. 18.028. Alright? So it's 18.028 over 236. So we have two values. of x. Let us see what they are. There we have it. Now, we're going to have 35 plus this. Let me put them in brackets. 35 plus all of this, right? Divided by 6 equal. We have 8.838 and also 35 minus that. And we have 2.838. So we have 8.838, 2.838. No, 8.838, 8.2, 8.829. Alright, so let's write them down. 8.838, 8.838, and x is also equal to, what is it again? My, it slipped out of my mind. So let's look back at it. 2.829. Alright, 2.829. So there we go. Now the thing is, which one of them is a max and which one is a min? Maximum and minimum value. Let's call them x1 and x2. Now, you remember how you can find the maximum and minimum value? Remember, you have three main methods. You can find what is v when x is 8.838, then what v is with a number to the left of 8.838 and then to the right, and see if they drop. And this is the highest, that would be a maximum. Do the same thing here. Alright, and it would be a minimum. But that will take too much time. The other one is to find the gradient at 8.838. Find the gradient at a number close to it like 8, and then find the gradient at 9. If the one here, well, you know, the 8.838, you would need to find the gradient at 8.838. You know that it is 0. But if the one at 8 is positive and the one at 9 is negative, you know this would be a maximum point. And if the one at 8 is negative and the one at 9 is positive, it would be a minimum point. But again, that would be taking too long. What we going to do, you remember the third method? Make sure you remember it. You're going to find the second derivative. So, d square v by dx squared. Alright? Let me check on something. Let me see how much battery I have. Alright, I have a good amount of battery left, because I can't see the battery from here. Alright? So, here now, what we have is d square v by dx squared is equal to, differentiate this again. We have 12 2's would be 24x minus 140. That's what you got when you differentiated it. So, let us see. Remember now, when we substitute, we're going to find, well, we expect one value to be positive and one negative, and then we talk some more about it. Right? Now, when x equal 8.838, d square v by dv squared is equal to 24 times 8.838 minus 140. And we find out what it is. And when x is equal to 2.829, then d square v by dv squared is equal to going to be 24 by 2.829 minus 140, and we find out what it is. All right, so let's go. Going to find out what is going on here. I can't see the battery from here when I open the calculator. But anyway, it's not this calculator I wanted, it's this one. So here now, 24 by 8.838 minus 140 equals, we have 72.112. Let's just write 72, and then we're going to try it again with the other value. All right, so we have it here. The other value is 2.829. 2.829. Negative 72. Now, you remember what it means when it's negative and positive? When you have the second derivative substituted and it's positive, it means there is a minimum value. Remember that the second derivative is telling you what happened immediately after you pass the point. If it is a minimum point, remember you're going from left to right, the gradient is going to change immediately from 0 to positive, right? The gradient is going to swing from a 0 to a positive value at the minimum point. Or you can think of it is that if you're walking and you're at the bottom of a valley, when you move after that, you must have been going up. You can't go down any further, you know, so any movement would be up. So you're looking at a rise, a positive. So this is a positive 72, it's a minimum point. And when it's a negative, it means you're at a maximum point. You see, at the maximum point, the gradient is 0, you know. Let me draw back the gradient here. It's a straight line. At the maximum point, the gradient is 0. This must touch the line. Right? It must touch the curve. Right, the gradient is 0. And once you pass the maximum point going to the right, the gradient will swing to a negative. It's going down. Alright? Another way that you can remember it is that when you're at the top, you go at the top of a hill and then you start walking again. You can't go up any further because you're already at the top. You have to be going down. So a negative movement, a fall, means you must have been at the top. You were at a maximum point. Alright, so here now. The maximum would be when x is 2.829. So 2.829. Let us look again at the container. All right. You have the container, and we're going to put on the dimensions of the container. Drawing this in too much of a hurry, you know. The lines, some of these lines aren't connecting. How this one go? So, and then so, and so. All right. So you have x we should be, let's just round to 2 point, call it 2.8. Let's round to one decimal place. Then we have 15 minus 2 times 2.8. Let's calculate that. So 15 minus 2 times 2.8, 9.4, and then we have the other one was at 20 now. 20 minus 2 by 2.8 should be 14.4. So I have 9.4, 14.4. 9.4, 14.4. So the volume, maximum volume, would be 14.4. That's a length times the width, 9.4 times the height, 2.8, equals. All right. Let us see. So 14.4 times 9.4 times 2.8 equal 379. 379 would be the maximum volume, right? So you have 379 there. Now, here, we're going to look at what the curve is like. If you were to sketch this curve, you would see something like this. All right? That will be the curve. What was it again? 4x cubed minus 70x squared plus 300x. That's the volume curve. Now, what we could do is try a thing with GeoGebra and see if that is the curve that we would get. Now, at the same time, what you can do as a homework, change the 2.8 to 2.5. Or we could do it here. After we look at the curve, we'll do it. It's taking some time to open, you know. GeoGebra is taking quite a bit of time. But let us test this thing out to see if it really is the maximum at that point. Suppose we have two other volumes. Suppose we had cut off, instead of 2.8, we cut off 2.5. So we go a little bit under 2.8. You would have 2.5 high times, the next one will be 20 minus 2.5 by 2 is 5, by 15 by, and we have 15 minus 2.5 at one side, 2.5 at the other side, meaning you minus 5. So it would be 10 equal, and so this is one value, 2.5. So we cut off less than 2.8. Suppose we cut off more than 2.8. Then we would have, say, 3. 3 high by, if we cut off 3 on one side, 3 on the other side of 20, it would be, you lose 6, so it would be 14 times. And then if we have the 15 and we cut 3 from one side and 3 from the other side, right? 3 from one side and 3 from the other side, we would cut off a total of 6. So it would be 15 minus 6, which would be 9. I expect that if this 379 is indeed the maximum, then these two values should be less than 379. Let me just check if GeoGebra had opened. It's opening. My gosh, it hasn't finished opening yet. Anyway, calculator. Waiting. All right, our calculator is here. Oh, GeoGebra had finally opened. All right, I'll soon come to it. So here now, the values we're looking at. Let me get GeoGebra out of the way, and this other calculator too. The values we're looking at are 2.5 by 15 by 10. All right, it dropped from 379 down to 375. Let's look at this one. Suppose we have 3 by 14 by 9. It dropped from 379 to 378. So we have 375, 378. 375, 378. So you see, this was indeed the maximum point, the maximum volume. Suppose we looked, for example, at 8.8. Suppose it was 8.8 we cut off. What would happen? What we would have is a volume of 8.8 high times, well, that would be impossible because first of all, 8.8 by 2, 16.16, 16.16, so it would be 20 minus 16.16, all right, times, the width would be what? If we say 15 minus 16.16, we would get a negative value, so this couldn't work. So here, the maximum volume is indeed 379, and I should put unit, you know. Oh, it was in meters. It was in meter. So 379 meter cube. All right. Let's look at the graph. I wanted to look at the graph using GeoGebra. So we had 4x cubed minus 70x squared. Where's GeoGebra again? Let me open it. Let me open. All right. GeoGebra. It's taking. Oh, is it here, man? So we have, what was it again? 4x cubed minus 70x squared. So 4x raised to the power of 3 minus 70x raised to the power of 2 plus 300x plus 300x equals. All right, we're going to have to zoom way out to see this graph properly, because of all of those large numbers, the 300 and the 70 had and so on and so forth, right? So we see part of the graph already. We have a minimum point on the right, but we have a maximum point way up here, right? So it's from the left, it goes up, then down, then up again, right? So it's something like that. Goes up, down, and up again. So you see that. So the maximum point was when x was, what was it again? 2.8. So the maximum point occurred at x equals 2.8. 2.8 is somewhere here, and if we line it up with this, all right, 2.8. So that is it for this video. I will see you in the next video.